All right, 7th grade. Today we're going to review lesson 10 of chapter 8, where you're solving equations by graphing and then solving systems of equations by substituting. So let's talk about how to solve by graphing again, and then at the end of this video we'll do some examples right out of your work, okay? Remember when you're graphing equations, this first number here is always your slope, right? And this is your y-intercept. So just a reminder of that. I know we had an Easter break off to forget some of that stuff, but don't forget about that. So let's graph that first line. We should put a dot at -2. So dot right here, right? Because that's our y-intercept. And then our slope, remember if you have just a whole number, think of it as being over 1, right? Remember this top number tells you how much down or up to go. And this bottom number always tells you how far to the right to go. So since it's a negative number, we're going to go down 2 to the right 1. Down 2 to the right 1. Down 2 to the right 1. And so on. Okay, and so now if I connect those dots, so there's my straight line connecting my dots, and now I'm going to graph the other one and see what happens with that one. Notice the next one has a slope of -3, so I'm going to think of it like -3 over 1, right? So we're going to go down 3, right 1. Now notice there's nothing here, so you can think of it like +0. In other words, we're going to start at 0, 0. That's our y-intercept. Down 3, right 1. 1, 2, 3, right 1. 1, 2, 3, right 1. And you can see 1, 2, 3, right 1 already where they're going to cross because my dots overlapped. So notice if I connect my dots with a straight line, there's a clear spot where they overlap right here, right? Or where my two lines overlap. So don't forget to write your solution. Your solution is the spot where they overlap. So they're overlapping at 2 left and right, -6 up and down. So that's my solution. So that's graphing to solve a system of equations. You graph both lines. Remember, this first number is your slope. Second number is your y-intercept, okay? And then you look for the spot where they cross, and then don't forget to write that down. Now, they may not cross right at a nice intersection like this one did always, okay? But usually they will. But if they don't, you could have an answer like -1.5, 2.5, or something like that. That can happen. Okay, so just be aware of that. I don't know how many of those on our assignment will happen like that. I think most of them will end up crossing at intersections. All right, let's talk about solving then by substitution. Remember these ones? Substitution means putting one thing into another, right? Notice how this is our top equation right here, okay? And here's our second equation. Notice this one's the simple one. Always put the simple one in the more complex one. It's saying y equals 12. Okay, so if y equals 12, that means I can put 12 right in that top y. So let's do it. 12 equals 7 minus x. Okay, and so now I need to get x by itself. So I'm going to move this 7. Okay, that's gone. 12 minus 7 is 11. 8, 9, 10, 11, 12. 5, right? Equals -x. Now, if you ever have just a negative number, you got to think of it like that. Like -1x. Okay, and we still have to move that -1. So we'll divide both sides by -1. And we get -5 equals x. And so there you go. And so your solutions are -5, 12. Because y, they told us already at the beginning, right? So I just put that in the y spot. And here was my x solution. So don't forget to write your solutions like ordered pairs like we just did there. Let's do another one. Take a look at this one. Here's my longer equation, right? Here's my really simple one. So let's take the simple one and let's substitute it into the longer one. So if y equals 3, that means I can replace my y with 3 on that first one. And then my goal is to get x by itself, right? So let's start with the piece that's furthest from the x on that side. So let's take away 11 from both sides. That's gone. Now 3 minus 11. Remember when you have a small number minus a bigger one, think of it like this. It's like you're adding 3 plus -11. So different signs. So subtract and use the sign of the bigger number. So we get -8 there, right? So we get -8 equals 4x, okay? And now I still need to get x by itself, so I'm going to do the opposite of math here. I'm going to divide by 4. So I end up with -8 divided by 4 is -2. So there, once again, I solved by substitution. So now my full solution is, here's my x, right? And my y we can bring back from the beginning over here. So there it is. Don't forget to write your solutions that way each time. Let's do one more like that because this one's a little bit odd. Notice here's my longer, more complex equation. So I'm going to put the easier one right here into the top one. Notice y equals 2x this time. So I'm going to put 2x where that y is. Now notice there's a negative sign there. That's okay. We're going to leave that negative sign be. There it is. And then for y, I'm going to put in 2x. So notice it ends up making my 2x negative. That's okay. Plus 5x equals 30. Okay, let's combine our two x pieces on this side. Negative 2 plus 5. Notice we're adding numbers with different signs, so we subtract and use the sign of the bigger number, 5, right? So I get 3, positive 3. So I get 3x when I combine these two x pieces. I can combine them because they have the same variable, right? 3x equals 30. Okay, and then I can divide by 3 to finish it up. So I get x equals 10. Okay, now remember your full solution should be written like this. Okay, y equals 2x. So if y is 2 times x, what would y actually be? Here's my x, right? My x and my y. So y is 2 times x. So some of these at the end, you have to substitute what you got for x back in to solve. So let's put a 10 right where that x is. Y equals 2 times 10. So y is 20. So don't put 2x in for y. Put 20, because that's what 2 times x is. And so there's your full solution. Okay, let's do one more, because this one's a little bit funky too. Notice here's my longer equation. Here's my shorter one. I'm going to take this shorter one and plug it into the longer one. Notice y equals 5x. I'm going to put 5x right where that y is. So here we go. 4x minus 2, and I'm going to put it in parentheses. 5x, right where the y was. Okay, so I get 4x. Now I got to do a little math here. Negative 2 times 5x gives us negative 10x equals 20. Okay. Now notice I can still combine these two x's. 4x take away 10x. So notice I have a smaller one minus a bigger one. So I'm going to think of it like this, which means I really should subtract and use the sign of the bigger number, right? So negative 6x. So I get negative 6x equals 20. Almost done. Okay, I'm going to divide both sides by negative 6. Okay, and so I get x equals negative 20 over 6, because a positive and a negative, right? Now I can reduce these. I can divide them both in half. X equals negative 10 over 3. Okay. Now I'm not done yet, because that's just my x. Now I need to get my y. Now notice this one is not one that gave you the y right away. It says y equals 5 times x. Okay, so in order to get my y, I got to put my x right here, right? And then I can solve. So y equals 5 times what x was, negative 10 over 3. So if I put a 5 over 1, let me erase a little bit to get some stuff out of the way. Okay, so if I do my multiplication, I get negative 50 over 3. And I can't reduce that at all. And so there's my y. So I get negative 10 over 3, negative 50 over 3. There's my x and there's my y. So sometimes at the end, once you get your x, you can't just write 5x for y. You have to solve what y is. So put your x that you got right here in for this x and then solve. And you'll get your full pair. Okay, here's a couple right out of your assignment for today. The first four you do need to solve by graphing. So let's do the first one right here. Now remember, this is your slope, right? And this is your y-intercept, okay? Now remember your slope, if there's nothing there, I don't see anything before the x, you got to think of it like 1 over 1, right? So we're going to go up 1, right 1. But we're going to start at negative 9. Now careful, what's a little bit weird about our graphs today is they don't go by ones. Notice they're counting by fives on the y-axis. So what you're going to want to do to graph these, instead of looking at the y-intercept and the slope, what we're going to have to do instead for these ones is we're going to have to make an xy table, okay? Because these ones are going to be a little tricky to do the other method of using the slope and the y-intercept. So let's just make an xy chart. That'll help us get these spots. So for that top one, x minus 9, okay? And so we're going to, let's do some x values that'll give us some nice numbers. So like, for instance, if I put 10 for x, y equals x minus 9. So if I put 10 here, I'm going to get 1, right? Okay. What if I put like 19 for x, right? So if I put 19 here, 19 minus 9 is 10, right? Okay, and then let's pick one more value. Maybe 0 would be good. So if I put a 0 right here, 0 minus 9 is negative 9, right? All right, that gives me a few dots to graph. That should give me a pretty straight line. So x10, right, left and right 10, y1. Notice it's going to be barely above the line, because notice that the first y line is 5. So be careful. Don't put it too high, right? We're not going by ones. All right, and then 19x, 10y. So 19x would be about right here, and 10y would be about, so not quite to 20 left and right, okay? And then 0x, negative 9 would be about right here. So that should give us enough to make a pretty straight line. So there's our line going through those dots. Now let's make an xy chart of the other ones. Let's use red this time. So here we go. We'll choose some x values that make sense. How about we do like x is 5, 10, and 15, because we'll count by 5s with our x's. That'll make it easy to graph. So notice if I put a 5 in here for this x, 2 times 5 is 10, plus 4 is 14, right? All right, let's erase that 5, and let's put a different number in for x this time. Let's put 10 in for x right here. 2 times 10 is 20, plus 4 is 24, okay? And let's put a 15 in there for x. Here I go, putting a 15 right here. 2 times 15 is 30, plus 4 is 34, okay? So now we can graph our dots. 5, 14 would be about right here, right? Okay, 10, 24, so that would be about right here. And then notice that next one would go way off. So let's get one that's a little lower. What if we put like negative 5, in there? Because notice 15, 34 would be way off our graph. Let's try negative 5. So if I put a negative 5 here, I get negative 10 plus 4. Notice they have different signs, so I should subtract them and use the sign of the bigger number. 10 minus 4 is 6. So negative 5, negative 6 would be about right here. That should give me enough dots to make a pretty straight line going through. So here we go. Notice when I put that straight line in there, I know it's a little bit tricky to tell. What I'm going to have you do on these graphs, because it's hard to tell, is look for the spot nearest an intersection where they cross. So can you tell where that one crosses? That one seems to cross at negative 10, negative 20. It's close. I know my lines weren't perfect straight, but it was pretty close to negative 10, negative 20. And so we'll use that as our solution. All right, let's do another one. Notice number 3, which we're going to do next, is not in the right order. We need to fix it. So I'm going to rewrite it right here. And let's fix this. We need to get y by itself. So I need to move this 1/2. So we're going to divide both sides by 1/2. Okay. And remember, when you're dividing by a fraction, you flip it and you multiply it times the reciprocal, the flip, right? So I'm going to flip this and multiply everything on this side times 2 over 1. Or in other words, times 2. So everything. So y equals 8x minus 12, because I took everything times 2. Okay, so y equals 8x minus 12. Again, they've got this really funky graph here that's going to make it hard to graph it using just the slope and the y-intercept. So we're going to make an xy chart again to help us graph this a little bit better. And let's use some of the x values that we have on the... All right, let's see. Let's use 0 for x. That's always an easy one. How about like 2 and negative 2? Okay, so if I put a 0 in where the x is, 8 times 0 minus 12. 8 times 0 is 0, minus 12 is just minus 12, right? If I put a 2 in where the x is, 8 times 2 is 16, minus 12 is 4. And if I put a negative 2 where the x is, I'd get negative 16, take away 12 more, negative 28. I don't know if that's going to fit on our graph real well. What if we do like a -1? How about that? If I put a -1 here, sometimes you just have to play around with some values. 8 times -1 is -8. Take away 12 more, -20. That'll give me a pair that will fit on our graph. Okay, let's put our dots. So 0, -12. Okay, so that would be about right here. Not quite halfway to -15, because this line right here would be -10, right? So a little past -10. Okay, 2, 4. So 2 is not quite halfway to 5. 4 is not quite all the way to 5. So that would be about where 2, 4 is, right? And then -2, 28, remember, wasn't going to fit. So let's do -1, 20. So -1, -20 would be where? So -1 left and right. And a -20 is going to be this line down here, right? So our dot's going to go about right there. So you notice we're going to get a straight line when we graph this. Okay, let's do the other equation. We'll go blue this time so it's not confusing. So we have 1/4 y equals 2x minus 3. So again, we got to get y by itself. So we're going to divide both sides by 1/4. So this cancels out, right? And remember, when you're dividing by a fraction, you flip it and multiply it times the reciprocal, or the flip, right? So I'm going to flip that upside down times 4/1. So in other words, we're going to take everything over here times 4, right? So 8x minus 12. There. We fixed it. All right. So again, this is going to be, because this chart doesn't go up by ones, it would be hard to graph it just using the slope and the y-intercept. So we're going to use an xy table again. Sometimes you have to do that. And let's just do like 0, 1, and 2. I think that'll work okay on this one to use those three values. 8 times 0 is 0, minus 12 will just be -12, right? If I put a 1 in where the x is, 8 times 1 is 8. 8 take away 12. Think of it like this, right? 8 plus minus 12. In other words, subtract them. Use the sign of the bigger number, right? So -4. And if I put a 2 in there, I get 8 times 2 is 16, minus 12 is 4. Those should be some pretty nice pairs to graph. So 0, -12. Notice I think I found our overlap spot already. 1, -4. So 1 left and right. -4 would be about right there. And 2, 4. Do you see what's happening? We're overlapping perfectly. Whenever that happens, that means you have a gazillion solutions, because your lines are overlapping completely. And so your answer for that one would be infinite solutions. Okay, so if that happens where your lines completely overlap, you say that there are infinite solutions, because they're not crossing like this and having one solution spot. They're completely overlapping. And so then you have infinite solutions. So I'm glad we did that one together. That one was a little bit strange. All right, let's do a few of the substituting ones. Let's do like 10, 12, and 14. Notice 10, y equals 2x, and x equals -4. So let's take this second one, and we'll substitute it into the first. So if x is -4, I can put a -4 where that x is. So 2 times -4. Don't forget to show this work, okay? So y equals -8. So now I have my two solutions. Remember, our x was right here. Here's our x and here's our y, right? -4, and we just figured out y is -8. So there's my two solutions for number 10. Let's do number 12. Okay, notice here's our big, more complicated equation. Here's the easier one. We're going to substitute this one into that one. So if y equals -4, that means I can replace the y with -4. So let's do that. Okay. Now my goal is to get x all by itself. Okay, we can do that. Let's start with the piece that's furthest from the x. So let's take away a 5 from both sides. Okay, -4 take away 5 right here. That'd be like this. Or in other words, like you're adding two negatives together, right? So that'd be -9 equals 3 times x. And then you can probably guess what the last step's going to be. Divide both sides by 3, right? So we get x equals -3. So now I have my two pieces that I need, right? I need my x and my y to write my solution. Here's the x. We just figured it out, right? Remember the y they gave you at the beginning, -4. So let's do one where you don't have a piece at the end, okay? So let's do this last one right here, 14. Take a look. It says, here's my first equation, right? Here's my simpler one, y equals x. So if y equals x, Okay, that means for this y right here, I'm going to replace it with x. So here I go. 26 equals x plus x. Okay, this is a little bit weird, but let's combine these two x's. Think of this like 1x and 1x, right? So 26 equals 2x. See how that works? Then we have one more step to solve. Divided by 2, divided by 2, right? So 26 divided by 2 is 13. So there's my x. Now what's my y? If I put a 13 here. Now y equals x. So y is the same as x. Oh, so it must be 13 as well. That was a little bit of a strange one, but not too bad to solve. So hopefully that gets you going. I know this is kind of a challenging worksheet on the top when you're graphing especially. Take your time on those. Now remember, I'll let you estimate where they're crossing. I wish they wouldn't have given you graphs where it was jumping by fives because it's hard to tell what pair exactly it's crossing at. But find the spot where they cross and make an estimate as to where you think those lines are crossing. What's your solution? And then don't forget to always write your solutions for the graphing ones and for these ones right here where you're substituting like this as an ordered pair, okay? Let me know if you have any questions. I'll be happy to talk you through any of this. Have a good day, guys.